Hello and welcome to Workshop 4. In this workshop, if we haven't already got a pre-created server, which we should by now, we need to create a headless server and install bind. The main part of this workshop is really configuring bind 9 to now deliver a primary DNS service. Now we're going to do it in two ways. We're going to do it with forwarders and non-forwarding. In effect, we're going to use a designated DNS server, which we will then forward queries on, and we've seen that already. And then the other way we're going to do it is to remove the forwarding, so what we will end up with is using the root hint servers. The other thing we're going to do is we're going to add some entries, as in we want to make a primary server, and then we're going to identify the activity that we get based on that. Okay, so where do we need to start? I'm going to assume we all have our server. If you haven't, you're going to have to create one. But we can reuse the one from the last session. So what we need to do then, first thing we need to do is configure a student.co.uk domain. Now we can follow the lecture notes, which you already have. Once we've done that, we will have a zone created and we need to add some mappings. So what I'm going to do is do the first part of creating this zone. So if we have a quick look, here's my server that I created. I can do a quick ping test to make sure I've got access to the internet. My machine is running quite happily. If I do an IP-4A, I can see the IP address 10.168.100.150. It's statically addressed as it was before. Now, rather than do this directly on the console, which we can, what I'm going to do is I'm actually going to use my desktop that I created. So this machine will log in and we'll do the work through a remote connection. So what's the first thing I need to do? I need to create the student.co.uk domain. So let's quickly go to the server. So SSH student at 10.168.100.150. Put in the password, which should be Northumbria, and I'm connected. First thing I should do, it says no updates can be installed immediately. We'll just do a quick check. Sudo apt update. Let's do some quick checking, something we should do on a regular basis. It's fetching some information, so there's obviously something there. And 13 packages. Okay, let's do the upgrade before we continue. Yes, we'll take the upgrades. We'll keep an eye on that. Upgrade our core. No, nothing major coming in. A little bit of net plan updating in there, but we should be okay. Okay, so we're all done. So we're now up to date. Okay, let's clear the screen. Clear. And let's start. First of all, let's go to the etc folder and into bind. If we have a little look in here, ls-la, we can see we've got bind keys, db, they're the db files we're talking about. We've got local, and we've also got some reverse lookups. So we've got name.conf and name.options and name.local. So first things first, let's go into named.conf.local and create our link to the domain we want. So we go sudo nano named.conf.local. Now in here we define our zones. So let's define our zone for student.co.uk. So it's zone and then in quotes student.co.uk. So that's me saying this is my zone. If I now quickly put in my brackets, the next thing I want to do is I want to quickly go back from there, put my semicolon in, give myself a little indent, and then this is going to be type master. Oops. So this is going to be the zone that we want. Now because we're defining a zone, we're going to have to put in a file. Now when we're doing slaves, there's an issue where we can put slave files in as well, but we'll come on to that about optimization later. But for now, we want to go, this file is located in, notice the slash at the beginning, /etc/bind/db.student.co.uk. So the naming convention is db with the URL after it. Okay, that's the first part. If I save that, we're now ready to actually create the database file. So let's do that next. So what we want to do now is we want to copy that file. So here we go. So sudo cp db.local, and we want to copy it to db.student.co.uk. Now we can go sudo nano db.student.co.uk. So if we come along, we've got our default TTL, we put our origin in, and that will be student.co.uk with a full stop on the end. And we're not defining localhost, we're defining student.co.uk. Next thing, well, we'll just say that my email address would have been cgne1@student.co.uk. And we have a serial number. Next thing we should do, serial number, we should automatically change it. We've got a tab there, which we don't want. So it's 2020 now. Month is 05 and the day is 13. Oh, I'll just check. Make sure I don't put anything in silly. Sorry, 14. Okay. So that's 14, and that's the first serial, the first build. Just indent that so it's nice. So that's 2020 05 14 00. So what's the next thing I need to do? Okay, well, my name server, we'll change that to be, we'll call it NS, but we'll call it NS1. Student.co.uk. With a dot on the end. This has to be fully qualified. Next thing I can do is I can actually come along, change that to NS1. So this is the name server 1. I can take this last line out because I don't want a quad A. I come along and put in the IP address 10.168.100.50. Okay, that's the minimal changes to actually set up my first domain. So let's save that and see how we're doing. So control, output, and we've written the file. Okay, let's test that. So named named check zone. We're checking for student.co.uk and the file is db.student.co.uk. Now I can just type in the file name here because I'm in the directory where the file is. So if I now run that, it's come back, giving me the serial number, says it's okay. So I have no errors there. Okay then, if that's the case, let's restart bind and see what happens. So sudo system control restart bind 9, and it's restarted. Okay, let's open up another terminal. So we'll open up another terminal and I can go new window. Okay, now this machine, which I'm now on, if I go IPA, I can see that my machine is configured and I have the address of 10.13, so that's fine. Do a quick cat. No, I won't do a quick cat. Sorry, what I'll do is I'll do a quick check up here on my wired connection. Wired settings. Have a look at this and have a look at the info on IP. Sorry, have a look at the details. And my DNS is set to 8.8.8.8, so it's not going to go to the right server. So let's change that before we go any further. So DNS, change it to 10.168.100.150. 10.168.150. Okay, apply that. Reset the card, and now I'm pointing to the correct server. Okay, so if we now go to the other window, so if we open that up and we go to, sorry, not the other window, this one, I'm on my machine. So if I now go ns lookup and I do a lookup for ns1.student.co.uk, there we go, it's giving me an answer. So we're getting somewhere. The server is now providing me with an answer. Okay then, what's the next thing we need to do? Let's move that out the way and let's have a look. Okay, we've got a profile. So let's get ourselves some information sorted out with that. We'll store the information there and we'll grab our calculator. So the profile, the mail server is stable and should allow long term, 2 months. So, okay, let's get some information. Mail server, 2 months. Right, what else? Me is very dynamic. So me, we set that to a cache of 0. That means it will not cache, sorry, TTL to 0, so it won't cache. Can change regularly and should not be cached. All other machines should use a default TTL of 2 weeks. Okay, let's see, 2 weeks. So our default is 2 weeks. So 2 weeks is 2 sevens, which is 24 hours. And there are 60 minutes in each of those hours, and there are 60 seconds in each of those. And the reason for doing that is because it says all machines should use a default of 2 weeks. Use seconds for the TTL. So 2 weeks is 2 times 7, which is 24 hours, 60 minutes in an hour, 60 seconds. So what does that come to? So we get 2 times 7 times 24 times 60 times 60. So there we go. So 1,209,600. Okay, that's our default. So let's get that in there then. 1,209,600. It's equivalent to that. Okay, so there's my values. So that's that done. Okay then. Let's move that out of the way and let's do it. Okay then. So what we want to do now is get our, there we go. Okay then, so we need to be logged back in. Oh, we've already got that. There we are, we're already logged in. Oops. Right, so what we need to do now, sudo nano db.student.co.uk Northumbria. Okay, so here we are. Okay, what's our default TTL? Well, we just calculated that. Our default TTL, we need that to be 1,209,600. So, oh, sorry, 1,209,600. Okay, next thing we need is, we need our mail server. So we'll put the mail server in as a mail at the moment. IN, a record, and our mail server should be on 192.168.100. What is it? 2. Okay, what's the TTL for that? Mail server is 2 months. So we can put the 2M in, just to get everything lined up nicely. Let's just line that all up. Okay, what else do we need? Well, we need www and www2. So www and www2. Now, IN, a record. Now, I'll put these in, but these will change. 192.168.100.2. www2 is the same, so let's put that in. It's an IN record, use default 192.168.100.2. What else have we got? We've got me, and that's IN a record, and that is 10.168.100.13 because that's the IP address of my machine. If I come along and have a look at my machine, if I do an IP -4A, we can see now that I have 13. So let's go back. So that's the 13. So where are we up to? www2, www, is it www, control, contain, and There. That was Control K to kill the line, Control U to put it back. I just swapped them round. Then I've got me, then I've got server, IN address, A, server is 192.168.100. And that's 21. I've got mail, I've left that at the top, and then gateway. Okay. Obviously this is not my gateway, because my gateway is a different address altogether. And that's 192.168.100.254. Okay, so that's them created. Now, I've got 3 records here, all with the same. The mail server, the www2, and the www. Now, it says in here, if we have a look, we should, where possible, use CNAME records for the services. Okay. So, we've got somewhere, we have a server providing services for all of those. So let's create that record, services. So IN, A record, 192.168.100.2. Now what I can do is I can CNAME all of these. So instead of the A record, if I change that to CNAME, oops, AME, CNAME. And what I want to do is point that to services. Oops. So that's now pointed to services. And this one can be pointed to services too. And the mail server can also be pointed there. Okay, so that's those done. Now we'll test these and then we'll do one further thing, and that is to put the MX record in. But we'll do that next. So at the moment, we've got all of those records in and they're done. One thing we haven't got in here is the MX record for the mail server, but we'll come back and do that. What we'll do is test those to make sure they're working. So we'll save that. Now, I've saved it, but missed one thing. Right here. I missed something. I've made a change. Make a change? I have to change that. So, we'll change that now to a 1. And we'll save that. So I've written the lines and exit. As I say, we'll come back and do mail in a moment. We've done that. If we now restart the service, we should now be able to test those records, which we'll do in a second. First things first though, let's test those records. So if we go back to my client machine, remember we might have things stored, so what I'm going to do is sudo systemd resolve flush my cache. Northumbria. Okay, so my machine's nice and clean. I've got it pointing to the actual server, the mail server, sorry, the DNS server. So let's test some of these. We're going to do that here, but I just want to have a little look at some of the stuff first. Get these tested, just make sure we're happy. First things, before we go anywhere, let's test that zone. I've just realised I restarted it and didn't even test it. Not a good idea. I should have done that, which I've now done, and that's fine. Okay, so I restarted, but I've tested it, that's fine. Point of note here, if you restart it, you don't get errors. If you just restart it, it will do its best to start everything. One of the ways we can actually test and check something has worked when we've restarted it is the system, the syslog. So if I go tail/var/log/syslog, I can look at the last few lines. Now by default it's 15, which isn't much. But if I go -100, that's the bottom 100 lines, and then I can pipe that through more. So tail -100 var log syslog, pipe through more, and now I can see the bottom of it. And if you notice at the bottom here, it says loaded serial number 12 managed keys. But if I come here, we can see right here that student.conf student.co.uk loaded with serial number 2020-05-1401. So it loaded. So that's good. We can hit the return key and we'll get more listed up, or we hit the Q key and it clears out. So let's clear that. So it loaded. So let us now go back to our desktop machine. I can do some testing. So if I do some NS lookups, I can look up NS1 again and I get an address. I can look up www and I get an address. But notice there's quite a strange one here. I look up www and I actually get now non-authoritative answer www.student.co.uk canonical name services. Name services.student.co. So it's actually the canonical name is redirecting. So that's working. So let's go back to the file and have a look and see why that would be working. If I go back in the file, what I've done is there's my name server record, there's my normal A records, but what's happening now is mail is redirecting to services, www2 is redirecting to services, www is redirecting to services, and I have a machine called services right there. So they will all come back as 192.168.100.2, but it's using a canonical name. Okay, so what do we need to do next? Okay, the mail server is stable. Well, all I've created so far is simply a mail address. I don't actually have an MX record in there, so that's what I need to do next. Okay then, let's sort out the next bit, and that is that MX record. Now, just to fix a little error we've got, I forgot to set that to 0. Never mind, that's sorted. Okay, next thing, let's sort out the mail MX record. Now the MX record is basically what allows us to look up a domain and say where is the mail server for that domain. So if I'm cgne1 at student.co.uk, you look up student.co.uk to find out where the mail server is. So we need to set it up for student.co.uk. Now the @ symbol allows us to say the actual origin. So it's @ for student.co.uk. The next thing is this MX record, we're going to set it up with a TTL now, and the TTL is going to be 2 months. The next thing is it's an IN record. Sorry, IN record, but it's an MX record now. Now the additional thing we have here is the priority. Now the priority is what allows us to sequence multiple mail records, but we're only going to have one, so we set it to 10. Let's get this all laid out a little bit tidier because I've now got an extra column. So I'm going to just indent all of this to get it to format correctly. Well, not format correctly, but it's just more readable if it's formatted. Okay, so, and then what we do is we actually say that the MX record points to mail.student.co.uk. It's usual when setting up a mail record to have the actual mail server name fully qualified. Now, you don't necessarily need that because it could point somewhere else, but in this case, it is pointing to the same domain, but we're going to still specify it fully. It's just a good habit to get into. Okay, so we fixed a few things here. We fixed them, so we need to now update the serial number. So our serial number now gets updated to 2. Okay, let's save that off. Let's exit out and let's do some testing. First of all, let's check the zone again. This time, MX mail is a C name and that is illegal. Okay, let's go in then. Northumbria. Okay, so I can redirect a mail somewhere, but that means MX has to point to an A record. It must point to an A record. So I can't point that to mail. What I would have to do is point that to services. It doesn't stop me having a mail as in a URL. because I may have a web interface to the mail service, so we'd go to mail. But when it comes to the actual MX record, we must point it to an A record. So that's what we've done. So we'll save that, we exit out, and we test it again. And now it works. So be careful with CNAMEs, always make sure you check things. Now we've tested it, what we can do is we can restart the service. So, quick restart of the service and we're done. Okay, let's have a test of those now, a little bit more of a test. If we go back to our base machine, so this is my base machine. Oh, I just hit return too many times there. Right, okay, Northumbria. Let's clear the cache. Now what I'm going to do is I'm actually going to do a lookup on those records again, which works. I can look up mail, and that all works. Now one of the things I can do is even using a canonical name, but now what I can do is if I want to look up the mail server, I have to actually say I want a specific type. Type equals MX record. So I'm now doing a NS lookup for student.co.uk, but I'm specifically saying I want the mail server. I hit return. Authoritative answer cannot be found. Non-authoritative answer, mail, student.co.uk, mail exchanger 10 services. Authoritative answer cannot be found specifically for services. So let's look up services and see if there's something gone wrong there. Services. It gives an answer. So mail exchange is trying to point to services, but services is now telling me it has a non-authoritative answer. So why is it non-authoritative? Okay, let's have a look and see what's going on. Let's clear the local cache. Northumbria. And then run the query again. There's the problem. I clear the cache, but I use the local cache to get the result. Even though I've got my DNS server set here, so even though I've got my DNS server set in here to 10.16150, I'm still not getting an authoritative answer. The reason for that is the local resolver. So if I want to actually get an authoritative answer, I'm going to have to direct this query away from my resolver. And to do that, 150. So I have to say, do the lookup for the MX record for student.co.uk directly off the server. So this is where we use NS lookup, but we specifically use or direct it to a server. If I run that now, if you notice it doesn't say non-authoritative anymore. That's because that is the authoritative server. So in effect, I'm bypassing the local resolver. So once we set it to our local resolver, we must clear it because it's caching, but I can still direct queries directly to the server. So now I'm able to do a lookup for that server. Okay then, so we've got that working. What do we need to do next? Query the server, each of the host names you added to the zone. Add the following to the host file. Okay. So all we need to do now is we need to go to the server and we'll add that record. So there we are, back to the server. Let's clear that screen, it's a bit messy. Okay, let's open up Northumbria. Let's go into that file. And if we go down to the very bottom, we can add in test. And that will be an IN record. It's an A record because it's an IP4 address. 192.168.100.99. Now, right now, I'm going to save that and exit. And what I'll do is I'll now restart bind to load the configuration files. Now, it looks like I've made a little mistake there because I haven't updated the serial number. But let's look what happens. If I go to my server and I simply go ns lookup test.student.co.uk, it works, but I didn't change the serial number. The reason for that is because of the timestamp on the file. the local machine knows what to do. The serial number, although I've said you should change it, otherwise things won't update, is because it becomes important when we start moving from a DNS server to a DNS service. So really what we're trying to do here is get into the habit of doing it. So let's go back. I didn't have to do anything, but I should have, just for good practice. What I should have done when I added that is, if I go back to my server, what I should really be doing is, if ever I add that record, add or increment this. So I increment it and save it. This is to actually do something what we call notifies. So rather than us get into this habit of building our primary, using the primary, because that's what we're going to end up doing quite a bit in this module, I would guess. But later, when we start introducing the secondary servers, we really need to be very vigilant with this. So let's get in the habit now. We know it's used to identify changes, and those changes are actually pushed through from the primary server to secondaries when we turn the server into a service. So as I say, it's all about practice. So good practice. So if we go down here, what did we have to do to make the addition work? Well, we just added the entry. However, there should be a little addendum we put in here to say, however, good practice, we should change the serial number. So I've changed the serial number. If I restart it and go back to our main server, obviously I'm using non-authoritative because I'm caching. So let's flush the cache. Now flushing the cache means it will have to direct the traffic and bounce it from my machine or the client machine to the server. So when I run this NS lookup this time, it's actually gone through, and it's still non-authoritative, but it's done the update. And we all know about how caching servers work. Okay, let's see what's next. Configure the DNS server so it doesn't use forwarders. For all these exercises, run Wireshark on the virtual PC, which we've already got running, and then carry out the queries. Okay. So let's go to our DNS server, and there is our DNS server. So if we go sudo nano /etc /bind /namedconf.options. In here we have the forwarders. So to stop using the forwarders, we simply comment out that. Let's try something first. We know how it works, but let's do this anyway. Let's leave that the way it is. So let's exit, save the buffer, no. We'll leave it running as it is. What we'll do is we'll do a query for Google. So we've got this running. We'll filter DNS traffic, and we'll look for traffic that contains Google. Interestingly, I spelled that wrong, so we'll just fix that. So it contains Google. So we're running a capture. Okay, so start capturing. We're only displaying here, so this is just a display filter. If I now go to here, and I now go to my local machine, what I'll do is I will clear my cache, just in case there's anything in my local resolver. So we'll clear that, and we'll run a query for Google. So we go ns lookup google.com. I'll just put the www at the front as well, because that's what it says do. And there we get a result. So let's have a look at Wireshark. If we go to Wireshark, we can see that it went from our machine to our DNS server. Our DNS server went to 8888. It's also used 8844 as well, but that's something we don't need to go into at the moment. But we can see it's used that forwarder. So if we go back and look at the forwarder that was set, we can see that it is in fact the ones we expected of 88888 and 8884. So what we'll do is, if we take these out, what happens? So we simply comment them out, save that, and restart the server. Okay, now I'm just going to assume it's worked here just for speed. But if we now go back to my machine, and I now flush the cache, because obviously I'm going to have some local cache there. If I go back to Wireshark, stop the capture, restart the capture, And now when I do the query, let's see where the query actually goes. Now, it seemed to take a little bit longer there, which it probably did. So if we go now to Wireshark and we have a look, right at the top, our machine went to 100.150. Then there's a load of IP6 traffic, and then we get the answer back. So not only did we not use those forwarders, we actually ended up using IP6 in this occasion to actually get the result. Okay, so not using forwarders means that the server has now used the root hints to get the answer, and it's done quite a bit of work to do that. Okay, so what else do we want to look at? We want to look at student. So let's have a look at student. So we're starting to search for student now, so let's have a look. So if we go to our machine, we've got Wireshark running. Let's stop it and restart it just for capturing purposes. And then we go back to our local machine. Now we do a search for www.student.co.uk. We do our lookup, we get our canonical name coming back, we go to Wireshark, and we've been to the server, and we've got a response, which is what we expected. So now let's do the same with me. So let's look at that, and what we'll do is let's see if this works a little bit better. Let's go me.student. So we just get me.student requests. If we now go to here and we do a search for me.student, I get my answer from the server. If I have a look, well, it looks like it came from the cache. So let's try that. Let's go back up here. Let's flush the cache and let's run the query again. Go to Wireshark. No, that doesn't seem to be working. Maybe the dot means something. In fact, it does. Let's go to me. Restart the query. Let's run it again. Flush the cache. Run the query. Go to Wireshark. We can see the query's been run. Stop the query. Recache the traffic. Go back to my machine. Rerun the query. Go back to Wireshark. And it's actually run it again. Now, why would it run it again? Why is it not in the cache? Okay, let's have a look at our database file. Why isn't it in the cache? And there's the answer. It's not in the cache because I've told it not to cache. Obviously, that's what we're trying to do here. Show that caching, we can disable it. So we have done that. Okay, let's drop out of that. And go back to our local machine. Okay, what next? Okay, we've run the query and we spotted the differences. The difference was Google used the forwarders, and when we run student, we didn't get any change because it was the same as before, but we did notice that me was actually not being cached because we'd set that to 0. Never mind. Okay, next thing we need to do is we now need to limit the student.co domain so only locally connected clients. Now, if you notice, it specifically says the zone. Because it's specifically saying the zone, what we will do is we will do this in the zone declaration, not in options. So what we'll do is we'll go and have a look at the options now, and what we'll do is we want to have locally connected clients only. So let's have a look at that and start building that component. So let's go back to our machine. Let's go back to the server and let's have a look and see what we need to do. What we need to do is not in the zone, we do it in the namedconf.local file. So in here, what we have is the student zone, and the student zone at the moment is open to being used for queries. So what we're now doing is we're now going to limit that down, and we're going to limit it by using the allow query directive. Now, the allow query allows us to do two things. It allows us to allow and deny. Now, at the moment, it's saying allow. Now, it's saying allow the local network. So if we have a look, locally connected machines. So that means on our subnet. So I can do that two ways. 10.168.0.0/16. That is my local subnet. So I could do it that way. However, the better way to do it is using local nets. Because local nets is basically a default way of saying the subnet I'm on. So let's do it that way. So we'll save it. We'll quit out of there and we'll restart the server. Okay, so if I want to query that, I should actually have no problem whatsoever querying student.co.uk. So let's do that. Let's query the server for student.co.uk. And it's fine, it still works. I'll clear the cache just to be sure. Yep, that works fine. So if you still get an answer, if you don't, check the configs. Well, it's worked fine, so we're okay. Now what I want to do is block the actual address now. So let's have a look and see what happens. So we're going to run Wireshark again. And what we'll do is we'll have a look at what happens when it's blocked. Okay, so there we go. So filter on DNS traffic. So there we go. DNS traffic is what we're filtering on. So if we go to here and run the query from our local machine, I get an answer. I'll flush the cache. So if I go along, have a look at Wireshark, and there's the queries that went through, basically hitting servers, etc. So that's one part of it. So let's have a look what happens if I clear the cache and run that again. But now what I'm going to do is, before I run that query, I'm actually going to block it on the server. So I go to the server, I edit the config file, and what I do is I add in. Now, where I add this in makes a difference. What I'll do is I'll add it in incorrectly to start with. So to incorrectly add it, I would have local nets followed by 10.168.100.13. And then say don't allow, so I put the not in. Okay, that seems reasonable. Allow everybody in there, but not that machine. Well, if we do it that way, restart the server, let's look what happens. I run the query and it still works. Flush the cache. Yep, that definitely still worked. So why did it still work? Well, let's flush the cache. Restart Wireshark, because then we can capture some traffic, and we'll see this all in one go. If I go to the server, what I've actually done there is I've used the access rules incorrectly. Tiny little mistake I've made. The rules are applied top down. So when we are actually checking a connection from a client, it sees local nets, says this machine's on the local net, and allows it through. So it doesn't even get to check the next rule down. So what we have to do is we have to have them sequenced, deny, then allow. So if I now save that, exit out and restart the server, what should happen now is I should actually be denied. So let's go to my client machine and try and run that query. And as you can see, it hangs. What's going on in the network? Well, it's not getting anywhere. Oh, and then, lo and behold, we get a refused. There we go, refused flag. So, I'm not able to query the server anymore. So that's the rules in and out for getting us in and out of there. And there we go, no server could be reached. It actually got a deny. It couldn't be reached, it was denied. Okay, so let's have a look what else we need to do here. Once you've got the ordinal, check the configs, and that's all worked. Okay, everything worked. That's the end of the workshop. Thank you.